Hey everyone, Mrs. Edstrom here. Welcome. Today we are talking about the unit rate and how to find that. So, if you're using the yellow note packets, we're on page 41. Go ahead and make sure that you have found that page. We're going to go ahead and talk about unit rate. So let's go ahead and fill in our essential question. So remember, our essential question, that's what we are answering when we're taking these notes. And when we're taking these notes, we are writing down what we're learning so that we can remember it later and we can go back and we can refer to these notes to help us with a problem. So let's go ahead and let's start off with our essential question. So what we hope to be answering today is the question, how do I find the unit rate? How do I find the unit rate? So with our essential questions, one of the things that I want to make sure you understand is that these questions are meant to help you find help in your notes. So when you're working on a problem and you're like, oh, it says to find the unit rate, I don't know how to do that. In your head, in a way, you're saying, how do I find the unit rate? And you're going to want to flip through your note packet and say, hey, look, here's that question I'm asking. This page is going to have the answers. And that's what we want to go through. So we are going to talk about the unit rate. Let me get rid of that sticky. There we go. And we're going to start off by defining unit rate. We can't find the unit rate if we don't know what the unit rate is. So when we talk about unit rate, we've been looking at rates, and a rate is a ratio. It's a comparison between two objects or two things. And a unit rate, we call it a consistent rate. It stays the same. It is a consistent or constant, let's write that, a constant rate. It is consistent, that's another word for this. But it's a constant rate, okay? That means it stays the same. It's a constant rate, it stays the same. Just like when we were talking about proportional relationships, right? That reduced fraction that was the same all the way across. That's not necessarily the unit rate, but it's a constant rate. It stays the same. It's not going to change throughout the situation, and so that's an important feature of this. But it is a constant rate, and it is expressed or written as an amount, as a quantity of one, as a quantity and a quantity is an amount. So it's expressed as a quantity or an amount of one. That is where our unit comes in. We are talking about a constant rate expressed as a quantity or an amount of one. So one of the most basic representations of this is how much something costs per apple, right? Talking about that, how much it costs per item that you purchase. So one way that we can write this is it is an amount. Let's see, where am I going to fit this in? I'm going to write it here. It is an amount per one unit. And that could be any kind of unit. That could be how many miles per singular hour. It could be the price per apple. It could be, we're going to look into some of these at some point too. One of the things we talk about too in stores is the price per ounce or pound, whatever we're measuring in. By the way, ounce, oddly enough, is shorthand is OZ. So ounce is OZ. If you see that, that's what that means. So when we're trying to find the unit rate, we are trying to find what is the amount per unit. Per whatever that unit is. Are we measuring in ounces? Are we talking about apples? Are we talking about how many hours? Are we talking about how many minutes? We're looking at all of those things to find this unit rate. So let's try to use this definition here to help us and see an example problem here. So Sue drives 120 miles in 4 hours. Ooh, there's a typo. How many? That's supposed to say miles. Did she drive per singular hour? So we know how many miles she drove in 4 hours. We want to know how many she's driving each individual hour. So we're going to start off by writing our fraction. And it does not matter which direction we write the fraction. However, I like to put the first unit above. So we're using this one here. We're using miles per hour. So since we're wanting the per hour, I am going to put the hours on the bottom of my fraction. That way when I read this fraction, I can read it as miles in hours. And we're trying to get this down to miles per hour. So we're trying to get that bottom number, that hours, to be 1. So we're going to take our fraction. We have 120 miles in the problem. And how many hours does it say in the problem? 120 miles in how many hours? Yeah, it says 4 hours. So I'm going to put the 4 below. This is where we're going to use our proportional statements. Often we can just divide. 120 divided by 4. Remember, a fraction is what operation? What operation is a fraction? Yeah, a fraction is division. So if you wanted to go set up on the side and you wanted to do 120 divided by 4, definitely would work. You can totally do that. You can also set up your fraction. And we can say, well, we know we want to have a 1 on the bottom. That means that I'm dividing 4 divided by 4. And when I reduce fractions, I divide the top and the bottom by the same number. Either way, we're going to end up doing 120 divided by 4. Let's take a look here. How many times, let's review long division. How many times does 4 go into 12? It goes in 3 times. 3 times 4 is 12. This is where we have a 0 here. But I don't just get to finish that there. 4 does not go into 120 only 3 times. I'm above the tens unit. So when I have zeros here, I have to go all the way over to our decimal spot, which means I have to fill in a 0 there because 4 goes into 0 times. That means that 120 divided by 4 is 30. So there's my fraction. Am I done? Ooh. The correct answer is no, I'm not done. I have a fraction, but we're answering a word problem, so my answer needs to be in words. So what does this mean? This says 30 over 1. This is where we can go back to our original problem here, miles over hours. And we can see that it is 30 miles per hour, per singular hour. So Sue is driving 30 miles per hour, which we can simplify to mph. If you wanted to write miles per hour as mph, that is fine. Or you can write the whole thing out. Alrighty, awesome. So at this point, you should know how to find a unit rate. This one's talking about miles per hour. So Let's try another problem, and we're going to practice kind of using what we did before to help us solve this problem. And this is how you should be using your notes to help you solve your practice problems in the future. So when it says Daniel drives 80 miles in 3 hours, how many miles will he drive in 5 hours? So this problem is actually a little different. It's not asking for the unit rate. But what I'm going to tell you is that when you are trying to figure these things out, finding that unit rate is a helpful in-between step before moving into that 5 hours. So let's try this one. So again, I am going to use the fraction just like we did above. We're still talking about miles and hours. So I'm going to try to keep my fractions the same, miles and hours. When I work on this one, I know that I have 80 in 3. 80 miles, 3 hours. I do want you to be practicing this reducing fraction because I've been noticing that some of you have been struggling with this. When we go to reduce a fraction to have a denominator of 1, just like we did up here, we are dividing the denominator by itself. So 4 divided by 4 up here, that means down here this one's a 3, so that means 3 divided by itself, divided by 3. And just like above here, I divided the same number top and bottom. I'm going to do the same thing here. I'm going to use that same number on bottom, and I'm going to divide the top by that same number. Alrighty, this is where we're going to practice some division. I'm going to use this summary box. I'm just going to cross that out. We're going to use this space to do division. 80 divided by 3. How many times does 3 go into 8? Yes, 3 goes into 8 2 times. 2 times 3 is 6. It's going to leave me with 2 when I subtract. And I'm going to bring down the 0. How many times does 3 go into 20? 3 goes into 20 6 times. 3 times 7 would be 21, and that's too much. So we're going to take it down to 3 times 6, which is 18. Again, leaves me with 2. Now I have no more decimals. I have a remainder of 2/3. This is where we can write it as 26 and 2/3. We can also keep going. We have a little decimal here. We have as many zeros after the decimal as we would like. 3 times 20 is, 3 goes into 20, how many times? Again, we just did that one, so 6. 6 times 3 is 18. Ooh, interesting. When we subtract that, we start to see a 2 again. We're seeing a pattern here. We keep subtracting to get 2s, bringing down zeros to get 20. We know that 3 goes into 26 times. This is where we have a repeating decimal. 2/3 is a repeating decimal, 0.6 repeating. We can talk more about that too if you have questions on that. So in this case, we can write this as 26.6 repeating. We can also write it as 26 and 2/3. And that's how many miles per hour Daniel is driving. We want to know times the 5. And some of these problems you may have access to a calculator on, but we're going to go ahead and remind you of these. So if we know that that's the case, that's the per hour, we're going to multiply. I'm going to do the 26.6. So this is a little bit rounded, right, because it's repeating. But I'm just going to use that to make our math a little bit easier here, times our 5 hours. So I'm going to use our box. I'm going to do this math down here. We are multiplying by 5. I'm going to break 26.6 into the 20, the 6. Oh, I do like doing thirds better, but I'll use this one. Okay, 0.6. Alrighty, so 5 times 20, that is 100. 5 times 6 is what? 30. 5 times 0.6. When we use our decimals with multiplication, I think of moving it out of the way and then moving it back in. So 5 times 6 is our 30. We have 1 with a decimal, so that brings our decimal in to just be the 3. So this is right around 133. I believe if you used all of the decimals, since we kind of just rounded it off, it would end up being, there would be an extra third in there. But we'll keep it right around here. Our answer is going to be right around 133 miles in 5 hours. So we always want to make sure that we are answering the question. If we write the full sentence like this, we know that we're answering the right question. If we say 26 2/3 miles per hour, then we know what question we're answering. But this one wants us to do the 5 hours. So we're going to be doing lots of division. There might be some decimals. There might be times when we give you a calculator. Make sure when you show your work that you are writing down whatever you type in a calculator, whatever division you can do, whatever multiplication you can do, show your work for that. And remember that we are looking for that per singular unit. The amount per unit, the price per apple, the price per ounce, the miles per hour. That is what we're looking for when we are finding that unit rate.